So I'm Erhan Ercan with Morphotonics.
My name is Stefan Steiner from Lightrans, Germany.
So we came up with the idea of putting together a consortium, a loose consortium where we could show everything from design to measurements of an AR surface relief grading based waveguides. And it started out with Lightrans.
Right, you reached out at that time, and for us as a software developer and a designer, also in the field of augmented reality, it was very interesting for us because usually if people or other companies who want to do augmented reality designs, they have questions about design, but they never tell us any kind of parameters or results or fabrication feedback. That's a pity for us as software developers and as opticians, optical engineers. And for us, that's, I think, was one of the opportunities we saw there in the collaboration when you reached out.
Yeah. So I think this was the case for every company in the consortium. We, as an equipment supplier of large area nano imprinting, shot as a glass supplier, as well as optofidelity on the measurements side of things, and NIL technology out of Denmark from mastering. All these companies basically do work for all the usual suspects, all the players in the AR world, but we cannot really publish any data based on the work we have done. So we decided, why not get together, do a complete cycle from design to manufacturing, again to metrology, so that we can actually publish our results using large area nano imprinting so that we can show the increased throughput and lower costs. And that's what we have done since 2022.
Yes, that's right. And I think the results were very good. So initially, it was not intended to show some final working demonstrator. We tried to keep it simple, quite simple design, and just show this complete value chain. But in the end, some guy just took the waveguide and put it in a demonstrator, right? Yeah. It was really impressive to see that that one working at a trade show.
Yeah.
And I think that's a really great achievement from this collaboration.
Especially in a world where people, companies spend billions of dollars with thousands of, engineers. And here we are. This was sort of a Friday afternoon project for all these companies. We're not saying that we did, the world's greatest waveguide design, but at least we showed the feasibility of manufacturing in high volume at lower costs, a waveguide that is high quality.
Yeah. And just with some persons from companies from different fields of optics, experts in their field, in this loose collaboration, I would say, and now we are going to further continue, right? So
we published the results at SPIE XR, AR, VR, XR exhibition in San Francisco most of the time at the end of January, beginning of February. In 2022, 2023, 2024, there was a presentation Stefan presented, which was a full house, packed audience. And then in the years after that, we did the presentations, posters, and next year, 2025 XR, SPA XR, we're also going to be presenting. So the loose consortium continues.
Right. And we try to push the limits, like for the design. That means we further, let's say, make the design more sophisticated by switching to slanted grating instead of
lower residual thicknesses.
Right. That means better optical performance, but also better, let's say, manufacturing quality. And I think
and then
industry.
Yeah, and then at the end of the day, the idea is that there is other alternatives to manufacturing that are out there, which other than a wafer scale manufacturing methods that can result in high quality, waveguides at lower costs, and that was sort of the main consensus and the idea that we were trying to show.
Yeah, and furthermore, we're also trying to, let's say, further analyze the optical performance in future and trying to get some further deeper understanding how deviations in the fabrication or imprint can affect the optical performance. And I think due to this open collaboration and that we are allowed to share all the details and the information, this can be quite interesting.
Yeah.